Hello and welcome to the Sambodhi series of SETU, where we discuss several basic concepts of statistics, linear algebra, and machine learning. And today, our topic is difference between standard deviation and standard error. Imagine that you are working as a data professional in a pharmaceutical company where the company has created a new drug which they claim will reduce the blood pressure for high pressure patients. But before launching the drug in the market, as the medical board have some strict regulations to quantify the effectiveness of the drug, you have been given the responsibility to measure the effectiveness of the drug. Now the question is, how can you do this? Now, to actually quantify the effectiveness of the drug, you assume that the easiest way is to apply the drug on each and every available patient and then actually calculate the effectiveness. But for obvious reasons, that is not possible. So, you pick up 10 patients randomly from different health clinics and apply the drug. The results show that by M1 their blood pressure is being reduced on average and the standard deviation is S1. Here S1 represents the spread of blood pressure reduction due to the effects of the drug. If the standard deviation is high, then this indicates that the individual responses to the drug vary widely. Now pause the video here and think, does this measurement of mean actually represent the actual mean of the entire population? To validate this, we take 5 different samples from the population, and as there are different people in each sample, we put different sample means, and the different sample means we put them in a single line. We observe that average reduction of blood pressure in every sample is not the same, and so as the standard deviation. Thus, we can conclude that the sample averages are not the same as the population mean, and there are some obvious errors for each sample mean with the population mean. Now, to reduce this error, we take the average of the all sample means, which is a more precise way to measure the population mean. But this mean of sample means is the actual population mean? Certainly, this is not the actual population mean here, but what we have managed is to minimize the error. This is called point estimate. Thus, we statisticians prefer to derive a possible interval in which the population mean may exist. So, we calculate the standard deviation of this mean of means with respect to the data set of 5 sample means which we calculated earlier. Thus, we get an interval in which the actual mean will lie, and this is called the interval estimation. Here, the standard deviation of capital M is called the standard error. This standard error actually represents how much our calculated mean of means is likely to vary from the population mean. Please note that even though here we have explained standard error via mean, we can calculate the standard error for any statistic. For example, sample variance. In summary, to quantify the effectiveness of the drug, first we took a sample and calculate the sample mean, and then based on our observation on different sample means, we concluded that there are obvious errors between these sample means the population mean, and to minimize the error we took average of all the sample means, which is called the point estimate. And now as we don't know the precise value of the actual mean, we calculate the standard deviation of the mean of the sample means, which we called standard error. and get an interval where the population statistic may lie. Please note that the length of the interval also plays an important role in estimating the value of the actual population statistic. For further discussion in this topic, we will cover the concepts of p-value in a future video. Thank you for watching this video till the end and hope you have grasped the concepts discussed in this video. Feel free to share your thoughts in the comment section below and follow this series for more videos on different topics of the data world.